Boyle's book, Boyle's Rules, a short essay written and read by Bruce Mills, otherwise known as the Obligate Pedestrian. There have been in the history of science a collection of times and places when and where there has been a reformulation of a science. These are often touted as being revolutions in science, and often that which came before is proclaimed after as being, in hindsight, a wrong-headed idea that led us astray. However, they should be simply seen as times when there was a review and consolidation, a cleaning out and restructuring in accord with the accumulated wisdom. The study of materials has been subject to many of these. In particular, it is said that there were two revolutions in chemistry. The first pivots on the book The Sceptical Chymist by Robert Boyle in 1661, and the other on the book The Elements of Chemistry by Antoine Lavoisier in 1789. The first is viewed as being about chemistry versus alchemy, and the second as being about oxygen versus phlogiston. Each is seen to be a triumph of empirical rationalism over armchair philosophizing. While these two books are important and significant works, the details of their context and contribution is more complicated than the mythical story of heroes and gods in the Greek style that is the usual first introduction to the history of chemistry that is given in the 21st century. It is easy to see a writer as a hero if the other players are swept from the board of history, and indeed this is the core of each of these cases. Running neck and neck with Lavoisier was Cavendish. While Lavoisier was writing a polemic of phlogiston that promoted oxygen, Cavendish, who was a shy but very accomplished practical scientist, examined both theories and published works that showed that each had their problems, but concluded that the phlogiston theory was mildly ahead on points in explaining material reactions. He developed the theory himself to the point where the phlogiston was identified with what Lavoisier would call hydrogen, and the hydrogen, in modern terminology, acid theory of Cavendish based on this was arguably a better and more modern theory than that of Lavoisier, who mistakenly thought that acid was from oxygen. His name oxygen means acid maker. Of course, part of this is that there are several different technical meanings of the term acid, including the acid-base definition and the proton donator definition. Acid has an informal meaning based on general human experience of materials, beginning with tasting sour, and this informal meaning is formalized in several different ways in the technical topic. This is a very common situation. It does not mean that the informal use was wrong. The division into several better defined concepts is one process through which science evolves and improves. In material science, there was a gradual recognition that materials that seemed similar superficially, like lemon juice and vinegar, might be different fundamentally, and that materials that seem different superficially might be similar fundamentally, like diamond and carbon. Each time this happens, it is not a work of genius, it is just the step-by-step evolution of the science. Lavoisier, in The Elements of Chemistry, emphasized the idea of a change of terminology. There was a point to this, but that point has been overplayed. An example of Lavoisier's reasoning is that butter of arsenic should not be so called because it was poison while real butter was not. He was said to have rationalized the terminology. However, what really happened is that he modified the terminology to fit the theory that had been developed over the past century, developed by the people he denigrated. In the older encyclopedic books on chemistry, butter of arsenic and several other chemical butters were oily-looking yellowish fluids, so the term butter was a technical jargon that was mnemonic based on the overt mechanical and optical properties of the material, not on whether it was safe to eat. Lavoisier changed the terms to be mnemonic of the role of each material in the theory that had been developing. There is justification for this, indeed. But the suggestion that the previous terminology was nonsensical is unjustified. In fact, the older terminology has the advantage of coding some information about the overt properties of the material. Arguably, it is better to align with the theory, but the theory did not exist when the terms were coined. The older terms aligned with the older theory, and when the quantum mechanics came in, a lot of the terms of Lavoisier were not really a good fit any longer. Boyle, in turn, is said to have rationalised chemistry in the sense of turning it to practical empirical studies rather than empty armchair philosophising. However, examining several earlier works by alchemists, such as Summa Perfectionis circa 1305 and the works of Al-Razi circa 900, it is clear that so too did the major alchemists. Al-Razi, 865 to 925 AD, was an alchemist in the golden age of the Islamic world. He was Persian. He emphasised observation and experiment in his work. He is credited with first determining the difference between chickenpox and measles and in suggesting a viable treatment for the former. He apparently doubted that gold could be manufactured, although I'm not personally convinced either way. In his book, The Secret of Secrets, he described practical details of the basic laboratory operations required in material and medical studies. Further, Boyle is often classified as an alchemist in modern terms. He was not so much claiming that there was a thing called alchemy to be eschewed, but that certain practitioners had become too disconnected from laboratory experience. This appears to have been a particular trend in the 17th century, but was not the rule throughout history. Boyle might have a point there, but the point was not about alchemy versus chemistry. Michael Sendivogius, 1566 to 1636, was a Polish alchemist. It was he who discovered that atmospheric air was not a single substance and that it contained a life-giving component which he called the food of life, but was later called oxygen. He developed a laboratory process for purification and creation of various materials, including acids and metals. He wrote a new chemical light and was praised for the direct clarity of his prose. His book might have been easily called A New Alchemical Light, but he was using Agricola's neologism chemistry. The preface by Boyle to the Sceptical Chymist starts with, "To give the reader an account why the following treatise is suffered to pass abroad so maimed and imperfect, I must inform him that 'tis now long since that to gratify an ingenious gentleman I set down some of the reasons that kept me from fully acquiescing either in the peripatetical or in the chemical doctrine of the material principles of mixed bodies." End of quote. Mixed is spelled with an X. The peripatetic school was founded in 335 BC by Aristotle. Aristotle presents the four elements earth, water, air and fire as being prime materials. Boyle seems to be admitting the chemical principles as being salt, sulphur and mercury. So his concern is in being not able to decide between these two different systems of prime materials. The concern of Boyle is more or less the same as the concern in the 1800s over whether ozone was an element, or in the 1900s over the precise collection of fundamental particles. For example, arguments over Feynman's partons and the quarks of Gell-Mann. This suggests that Boyle is using the term chemical to refer to relatively more recent theories and alchemical to refer to the older. This fits with the neologistic coinage of the term in De Re Metallica by Agricola in 1556. This historian William Newman appears to associate the atomism of Democritus with the salt-sulphur-mercury theory of materials, and Boyle appears to associate it with chemistry, while the idea of the plenum or continuum of matter, as espoused by Aristotle, is allocated to alchemy. In the 20th century, with much talk of wave-particle duality, this dichotomy might not be a dichotomy at all. But what this illustrates is the gradual firming up of the pragmatic distinction between the use of the words chemistry and alchemy, which were originally synonyms. The time of Boyle was the time of the founding of the Royal Society and the rise of mechanistic philosophy, which was to take over the modern world. The mechanistic philosophers disparaged the armchair speculative philosophers as being unable to provide any true science, that true science that only the use of experiments could provide. However, while the mechanistic philosophers often claimed that the earlier philosophers had no interest in experiment, an attitude that persists to the 21st century, they did actually have clear interest as demonstrated in their books and analyses of their results. The matter of whether Aristotle physics was experimental has been rather contentious, However, while it was long claimed to be obviously false and that any simple experiment would have demonstrated this, a recent analysis by Rovelli established that within the context of its scope, it most likely could not have been derived without the use of experiment. The distinction between the mechanistic and speculative philosophers may well be better described as like the distinction made by de Broglie between theoretical physics that uses physical intuition and whiteboard philosophizing, and the mathematical physics or analytic mechanics in which the mathematics must be rigorous and drives the whole process. The fact that the mathematical physics is clearly mathematics does not change that its small number of highly significant physical axioms are derived from observation and experimentation. The mechanistic philosophers, in many ways, were not so much promoting experiment over speculation as promoting intuition over rigour and bulk data collecting over mathematical analysis. Brahe and his collection over many years of masses of data about the position of Mars is a good example of this philosophy taken explicitly, and indeed, in this case, it led to great dividends when Kepler extracted the elliptical orbits and the inverse square law of gravitation attraction from the data. But subsequent work for the next several centuries on Newtonian mechanics, as it became known, was very much a matter of detailed non-experimental and very extensive and rigorous mathematical analysis based on force equals mass times acceleration. As such, this would all qualify in the 17th century sense as being non-mechanistic armchair philosophizing. In the development of electromagnetics in the 19th century, Maxwell, following the mechanistic philosophical attitude, attempted to find a direct contact description of what was going on. In the 21st century, this has been described as a dark alley that led science astray, but is precisely the same thing that Boyle and the Royal Society were trying to do and are lauded for it. So we come to the principle that Boyle, a man of his times, was standing for the word chemistry over alchemy and was following the mechanistic philosophy, which as part of its creed claimed that speculative philosophers, ultimately including the alchemists, were ignorant monkeys who did not know any better, and that if only had made an observation they would have realized this. A view which was rebranded several times but still persists into the 21st century. Even when, with quantum theory, many say that the mechanistic view of Newton are now antiquated. Also, Boyle was part of the Invisible College, an informal group that eventually turned into the Royal Society, which was founded on the principle of free publication of results. While this in modern eyes often makes him sound like a hero, keep in mind that alchemy was actually much more published than the usual crafts at the time. Usually, knowledge was passed from master to novice in the context of an apprenticeship. To do otherwise would destroy one's livelihood. The advent of commercialism broke the principle of the guilds. Boyle was an early advocate of this. In the end, his motives were not altruistic, and keep in mind the modern notion of trade secrets. Most companies desire that universities and academics give their work out for nothing, while the companies closely guard their own work and restrict other use by patents. Today, universities have been, for the most part, reduced to a source of cheap research labour for secretive commercial organisations. Boyle states that he hopes that the chemical philosophy will win out, but his mind is not quiet. He says, "For I observe that of late chemistry begins, as indeed it deserves, to be cultivated by learned men who before despised it, and to be pretended to by many who never cultivated it, that they may be thought not to be ignorant of it. Whence it is come to pass, the diverse chemical notions about matters philosophical are taken for granted and employed, and so adopted by very eminent writers, both naturalists and physicians. Now this, I fear, may prove somewhat prejudicial to the advancement of solid philosophy, for though I am a great lover of chemical experiments, and though I have no mean esteem of diverse chemical remedies, yet I distinguish these from the notions about the causes of things and their manner of generation. And for aught I can hitherto discern, there are 1,000 phenomena in nature, besides a multitude of accidents relating to the human body, which will scarcely be clearly and satisfactorily made out by them that confine themselves to deduce things from salt, sulphur, and mercury, and the other notions peculiar to the chymists, without taking much more notice than they are wont to do of the motions and figures of the small parts of matter and the other more catholic and fruitful affectations of bodies." End of quote. He goes on to lament various ideas regarding his dislike for how the older books are written, and to demonstrate that he is not so well versed in the understanding of the jargon and culture from which they arose. He then claimed for himself the task of clarification. However, he also then asked for leniency in his own failings, his self-contradictions and ambiguity, as his heart is in the right place. Of course, The Sceptical Chymist is still a moderately famous book 4 centuries later, so he may have done a better job of explaining. Or, more likely, his sensibilities were more 21st century, as was the case with Lavoisier versus Priestley. Though this is something of a circularity, as it was the books of Boyle and Lavoisier that were partly responsible for creating the 21st century sensibility. Boyle says that a well-known chymical sensibility is ubi pallam locuti sumus, ibi nihil diximus, where we speak plainly, we have said nothing, and says that this is the most clear thing that they have ever said. I'm not convinced that this was the long-term historical attitude of the alchemists, nor even the chymists of the 17th century, though I'm less sure about the latter. It also might depend on who calls whom what. Jean Baptiste Helmont, 1577 to 1644, said that water was the prime material for plants, and Boyle accepted this, but he did not agree that it was the prime material for inorganic things. Helmont is credited with coining the word gas rather than using air. Ultimately, that is not a scientific advance in understanding, but a linguistic issue. In some languages, the word for fluid is the same as the word for water. That does not stop them doing chemistry and thermodynamics, nor does it mean that they think that everything is chemically water. I note that Priestley, a century later, discussed the different airs that he had discovered. It is a point again that because Helmont is looked on favourably in the 21st century, he is often called a chemist. But he worked with concepts that today are said to be mystical and alchemical. At best, usually this is explained by saying he was in a transition from pseudoscience to science. We forgive him those views that we do not agree with and laud him for those that we do. Hence, he is a scientific chemist and not a mystical alchemist. A similar attitude is often held in regards to Newton. Helmont used the principle that air and water were the prime materials. One justification for this was the famous willow tree experiment. He had a willow tree in an isolated region, and he weighed the tree and the soil before and after an 8-year period. The tree gained 70 kilograms and the soil lost 60 grams. Helmont concluded that weight gain had come from the water it was watered with. Thus, this was evidence for the prime material for the tree was water. The tree was a form of water, as is ice. This argument dismisses what might have been absorbed from the air. Si ortus medicina id est initia physicae inaudita by Helmont, 1577-1644, posthumous 1667. Boyle, like many people, including Becher, whom he inspired and who was the inspiration for Stahl, who originated the phlogiston theory, was examining the question of which were the prime materials. This topic has been under discussion since the time of Thales and is still under discussion in the 21st century with the studies in quantum field theory, string theory and loop quantum gravity. Boyle claims that many publications included experiments the author had not actually conducted themselves and that do not come about in the manner described. However, Pseudo-Geber of the 13th and 14th century was an alchemist and was highly hands-on himself. While one can be a chemist and still just copy details out of other books, which were copied from other books. All of these complaints of Boyle are legitimate, and the focus on direct experience where possible and good explicit authority where not is very laudable. It is just not specific to alchemy versus chemistry, nor to the 17th century versus the 14th. Partly this issue is one of confirmation bias. It is a very common thing for people to think that an argument is weaker because they disagree with the conclusion, or stronger because they agree with it. Everyone tends to say then that the arguments of the other people, while having merit, perhaps are ultimately flawed. Boyle says as much indirectly. And indeed, I am not sorry to have this opportunity of giving an example of how to manage even disputes with civility, whence perhaps some readers will be assisted to discern a difference betwixt bluntness of speech and strength of reason, and find that a man may be a champion for truth without being an enemy to civility, and may confute an opinion without railing at them that hold it. To whom he that desires to convince and not to provoke them must make some amends by his civility to their persons for his severity to their mistakes, and must say as little else as he can to displease them, when he says that they are in error. He also says, I hope the specimena I have lately published of an attempt to show the usefulness of chemical experiments to contemplative philosophers will give those that read them other thoughts of me, and I had a design, but wanted opportunity, to publish with these papers an essay I have lying by me, the greater part of which is apologetical for one sort of chymist, and at least, as for those that know me, I hope the pain I have taken in the fire will both convince them that I am far from being an enemy to the chymist's art, though I am no friend to many that disgrace it by professing it, and persuade them to believe me when I declare that I distinguish betwixt those chymists that are either cheats or but laborants, and the true adepti, whom could I enjoy their conversation, I would both willingly and thankfully be instructed. End of quote. I'm personally hoping that in quoting Boyle here at some length to show what extent he was for or against alchemists, and to what extent he was or was not an alchemist. But by his direct word, he was for the principle of doing careful first-hand experiments to use as the axioms of reasoning. He was not against either alchemist or chymist, but rather against the charlatan. I will end with the ending of the preface by Boyle. To conclude, whether the notions I have proposed and the experiments I have communicated be considerable or not, I willingly leave others to judge. And this only I shall say for myself, that I have endeavoured to deliver matters of fact so faithfully that I may as well assist the less skilful readers to examine the chymical hypothesis as provoke the spagyrical philosopher to illustrate it, which if they do, and that either the chymical opinion or the peripatetic or any other theory of the elements differing from that I am most inclined to shall be intelligibly explicated and duly proved to me that I have hitherto discoursed, will not hinder it from making a proselyte of a person that loves fluctuation of judgment little enough to be willing to be eased of it by anything but error. End of quote.